So, help me out. What's degrees of freedom again? N minus 1. That's the formula for it. So somebody wants degrees of freedom, or on this t-score chart, you see there's a column degrees of freedom. But right now, it's N minus 1. The whole big interesting story around that, you can watch the video from yesterday if you want to see what that story is. Or if you don't care, hey, there it is. Why do we use t-scores? In what situation?
If we don't have
I like it. Why'd you come home so late? Wow, let me get a t-score. So be a little more specific. I think somebody started to say it. There's two things you want to look for. What tells me I can do some of it? Normal. Right? And either I say it's normal or N is greater than 30 for means, and then NPNQ greater than or equal to 5 for percentages. And then what's the second thing that tells me actually which score to use, T or Z? When would I use a t-score if I only know S? Bats only knows. No, only know S, right? So t-scores were invented to cover my ass for when I don't know the population standard deviation. I only have an estimate, namely S. I really want that to make sense, because how much more is there to that story? None. Now, where they actually get the actual exact numbers, there's a lot more to that story, but just the idea of why they exist, there's not much more to it than that. Okay, I like it. So, if I had a situation where I only know S, don't know sigma, and my sample size is 81, and I want to make a 90% confidence interval, can you find a t-score for that? Don't say anything out loud once you find it, except maybe bingo or something, but just don't say that answer. What? Well, that's interesting. Why are you so zoom out more than that? That's the problem. That bad boy.
Yeah.
What's the degrees of freedom?
Yeah.
80.
But you really are
And what's, here's another new thing. What's alpha?
Oh, yeah. Point.
That's right, it's got two tests. So what's alpha? 0.10.
10.
I like it. Alpha is the area in the tail or tails. And confidence intervals always make two tails. Today we're going to see some one-tail situations, which is a really strange sentence, but I won't. So degrees of freedom 80, alpha's 0.10, two-tail situation. So, oh, there you go. The Zoom is working again. It's always reboot kids when there's a problem. So two tails, 0.10, stop at 80. Yeah, there it is. 1.664, is that what you guys got? If I go all the way down to what do I get? Z-score. So I can actually use the t-score chart to find z-scores for those situations. Okay. I don't know how you guys feel about that. So let's say second situation, I know S, I don't know sigma. N is 209, and I want to find a 99% confidence interval. What will my t-score be? See if you guys remember what I said yesterday. Do I remember what I said yesterday? I think so.
You go to max, and then to 1 because, so then I, because remember that yesterday was like more, and then he said, oh, if it's more, then just go back in. It was like 40 something.
Yeah.
There's 200 minutes.
Yeah, yeah. I could be wrong. Maybe
You remember that, right? That
Yeah,
one
yeah.
told you. Yeah. Because there was like no rain something or something, and then he's like, oh, it's like this chapter. And then this one is.
So anybody didn't get their updated stuff from me? Where am I? Oh, yeah. All right, so what do we got here? What's the degrees of freedom? Technically, the degrees of freedom is 208. Do you have a 208? Do you have a 208? No. So what do you use? 200.
360 because I'm American.
Hmm?
Stupid freaking joke.
And what's alpha?
0.1.
0.01. Confidence interval, so it's 2 tails. 2 tails. 0.01. Stop at 200. So I'd use 2.601. Okay. So I interchangeably use E and T because they both represent the same thing. They both actually represent the number of standard deviations from the mean to a data point. It's just that the t-score distribution has been adjusted because there's that standard deviation we're not sure about. Okay, maybe, yes.
What if N was 299?
Yeah, I mean, once you get really close to, are they changing much up here? Are they changing? Look down there. They're changing a lot more up higher on the chart than they are at the bottom, right?
Yeah.
Yes. So if you had 299, you can use either one. I would be fine with either one. Yeah. All right. So I try not to do that to you because, again, if we were using technology, it could figure out exactly what the t-score was for every exact sample size. I don't care because you don't learn shit if you just do it all in technology. So we kind of trade off preciseness for learning, which I'm fine with. Austin, did you get your stuff back?
Not yet.
Okay, I think that's everybody. All right, so what we're gonna do is this. I have an immense amount of data right here. I mean, you guys can see it. It's like the Great Wall of China. You can see it from here. So, you guys all see that great big amount of data? I desperately need each of you to randomly select, what did I say? 20 grades from this. This is like all the grades up to this point in the semester for the last several years, or whatever, semesters, whatever, for 160. You guys semi with me? So I'm going to give this to you. Very first thing I want you to do is to figure out a way to choose 20 random numbers. Does that mean you go, I'm going to pick all the ones that end in .0? Is that random? Shit, no. Right? Okay, so you could do stratified. You could drop a pencil 20 times. It's that one. It's that one. Right? Whatever you want to do. All right, so do that for me right away when I give this to you.
Aren't human brains notoriously bad at picking random numbers?
Yes. Humans are really bad at doing a lot of things, but we still try to do them.
You said 20, right?
Yeah, right.
Whatever you were doing, stop doing it and pick 20 random grades from here.
Yeah.